All right, scholars, time for our next lesson. We'll start the way we always start. Hopefully there's comfort and routine. Please make sure you put your name and number up in the corner. We are going to be finishing Module 3 notes very, very shortly. We're just about done with Module 3. We've gotten through quite a lot, working with fractions, working with mixed numbers. Obviously going to be working with mixed numbers again today. Today is Module 3, Lucky Lesson 13. And it's been a little while. We're going to talk about estimating. Estimating sums and differences. So basically adding and subtracting. We're estimating sums and differences of mixed numbers. Just like when we were working with decimals, there are times where it can be very useful to just get an approximate number, an approximate answer, without actually having to go through and add or subtract everything. Or on the flip side, once you've added or subtracted, using estimation to very quickly check your answer is a very helpful strategy. So this will be Roman numeral X, 10, 11, 12, 13. There we go. Okay. All right. We'll do a little bit of vocabulary. It has been a while since we've talked about some of these estimation terms. So hopefully you have Roman numeral 13, estimating sums and differences of mixed numbers, because I am going to zoom in a bit. Our first vocabulary term. There we go. Our first vocabulary term, just like usual, we're going to talk about rounding. What is rounding? Okay. I know I give you this definition a lot, but it's very important to me that you remember specifically what rounding is. Rounding is changing one or more. Sometimes you only change one. Changing one, sometimes you change more. Changing one or more numbers. Changing one or more numbers to make operations easier. We want to try to make the operation mental, basically, something that you can do almost entirely in your head. So we change one or more of the numbers to make that go smoother, to make it easier. Like I always say, rounding gets confused for this next term pretty frequently. But really, rounding and estimating are two different things. They're very closely related, obviously. You cannot estimate without rounding, but they're still a little different. They're not identical. Estimating only happens after. Okay? After rounding. I know it's silly. Why am I repeating that 5 bajillion times? Well, if you try to do all of the work, you add, subtract, whatever, and then you just round the answer, you're not really estimating. Estimating can only happen after you've rounded, after you've changed one or more of the other numbers. After rounding, then you perform the operation. Again, you do not want to do the operation first. That's not estimating. If a word problem says about how much, if a test asks you to estimate, you've got to round first, then perform the operation. Okay. Now, most of the rounding we've talked about so far, especially with adding and subtracting, most of the rounding for adding and subtracting we've been dealing with 4 or less, let it rest, 5 or more, let it soar. And the reason for that is because 5, that central point we're working around, 5 is usually halfway between tens. 50 is halfway between hundreds. 500 is halfway between thousands. So on and so forth. We're going to think of something very similar with our mixed numbers, we're going to talk about number lines and halfway points. Okay. So to begin with, let me give you a mixed number. Let's do 3 2/5. Okay. Now if I try to put this on a number line, it's one of my little arrows that I love so much. If I try to put this on a number line, which, I've got to draw the line in, okay, it's going to be between two things. Because this mixed number has a 3 as its base, well, I know it's got to be bigger than 3. I've got 3 and a little bit more. So it's going to be more than 3, but it's going to be less than the next whole number. The next whole number after 3 would be 4. Yay. Now the question is 3 2/5? I'm going to put a line right here. This is our halfway point. Is 3 2/5 before the halfway point? After the halfway point? Is it the halfway point? I don't know. Now some of us may be thinking, ooh, I know. And that's okay. Make an educated guess. But before we write anything down, before I put anything on there, I'm going to show you a little trick. Okay. So here's a little trick. To see if a fraction is less than or greater than 1/2. And again, that's what I'm trying to figure out. I'll be able to estimate and say, is it closer to 3 if it's closer to 4, once I know where it is compared to the halfway point. And I could try to change 1/2 so that it has the same denominator as 5, and I'll show you how to do that in class, but this trick I think is a lot faster if it makes sense. To see if a fraction is less than or greater than 1/2, double the numerator. Double the numerator. That's going off the screen a little bit. There we go. Okay. Still going off the screen a little bit. Thank you, paper. All right. To see if a fraction is less than or greater than 1/2, double the numerator. Okay. If the new numerator is greater than the original denominator. Now I'm writing original just to make sure that that's really clear, but honestly, we're not changing the denominator at all. You're not doing anything with the denominator. Okay? If your new numerator is greater than the original denominator, then your fraction is greater than 1/2. It's greater than, it's bigger than 1/2. If the new numerator is greater than the original denominator. Basically what you're saying is if you had two of those numerators, it would be more than enough pieces to make a whole. I didn't say that quite right, so that probably didn't make a lot of sense yet. Let's write this last piece down and I'll show you a demonstration or two. Okay? All right, so if the new numerator is greater than the original denominator, your fraction is greater than 1/2. If your new numerator is less than the original denominator, then your fraction is less than. Remember, it kind of looks like an L. Less than 1/2. Now, I understand. Right now, that's probably a lot of words. Doesn't make a ton of sense. So let's go back to the original problem I gave you, 3 2/5. And let's take a look at it. Now, you notice I keep saying fraction, fraction, fraction. I'm not worried about the whole number part. All I'm going to do is take a look at the fraction, and I'm going to think to myself, okay, numerator is 2. I am going to double the numerator. Now, I know it's kind of weird. Normally, I'm always yelling at you, do both, do both, do both. But this is just for rounding. You don't have to do both. You're just going to say, what is 2 times 2? 4. Come on. 4/5. Now, if the fraction was equivalent to 1/2, 2 halves would be a whole, right? So doubling the numerator, 2 times 2 equals 4. Doubling the numerator tells us if we have enough pieces to make a whole or if we have more than enough. We don't have enough. Doubling it, 2 times 2 is 4. That's less than the denominator. Since the numerator, don't worry, I'll abbreviate it this time. Since the numerator is less than the denominator, we'll abbreviate that also, we will round down. Okay. Essentially, we're rounding down because this 2/5 is going to be closer to the 3. I'm going to go back to my number line. I'm going to show you what that looks like. Okay. Now I'm going to lengthen these lines just a little bit, make them a little darker, because I'm going to add some other lines in just a second. I want this one to be a little darker also because that halfway point is important. Okay. Now if I look at this entire distance from 3 to 4 and try to break it up into fifths, this is going to be hard. Okay. There's 1/5, 2/5, 3/5. So 1, 2, 3, and it kind of goes over the halfway point. 4, 5/5. Okay. 2/5, or more accurately, 3 2/5, would fall right here. We can see that that is less than the halfway point. Again, we prove that it's less than 1/2 down here by doubling the numerator and saying, I'm still not getting to the denominator. So this is going to round down to 3. 3 2/5 is approximately equal to 3. Let me show you some more practical examples. And as always, please know we're going to do tons of these in class. So if it's not clicking 100%, we're going to be doing a lot more in class. Okay. Let's say I give you 4 1/8 plus 7 3/5. Okay. Now I want to estimate. I don't want to actually add these things together. So I'm going to look at the 1/8. I'm going to double the numerator. 1 times 2 is 2. 2/8. 2 is still smaller than 8. That means this is really close to 4. And I know a lot of you are looking at that and going, I knew that already. That's okay. 7 3/5. Look at the numerator. Double the numerator. 3 times 2 would be 6. 6 is greater than 5. 6 is more than 5. That means that this is more than halfway from 7 to 8. So we are going to round this up to 8. And then from that point, 4 plus 8 is just 12. So if I went through and actually did the work correctly, 4 1/8 plus 7 3/5 should be approximately equal to 12. Not exactly, but pretty close. Okay. We'll go ahead and we'll do one more. Let's do 8 2/5 minus 7 1/9. 2 doubled would be 4. That is less than the denominator. So we round down. This would be closer to 8. 1 doubled would be 2. That's less than the denominator, so we round down again. This would be 7. And 8 minus 7 would be 1. So if I subtract the original mixed numbers, 8 2/5 minus 7 1/9, I should get something that's pretty close to 1 whole. It won't be exactly 1 whole. Looking at this, my guess is it'll be a little bit more, but should be pretty close. All right, I think that's enough for right now. Again, as always, we will do more in class together. If you have any questions, jot them down, and I will see you in class.